Let's talk about sleep. Sleep part 1. There are several parts of sleep. So today let's talk about sleep part 1. And David7sciencetheater@gmail.com. Alright. That is our banner. Don't forget to subscribe, share, and like our videos. See, subscribe for more and better videos. Subscribe. You will enjoy the platform. It's good. Like, because everything we give is good, and share to other students and other individuals also enjoy the science. All right. Before I talk about sleep, I want to take you through about the waves seen on an EEG and electroencephalogram. Yeah. So we have 4 waves. We have the delta, theta, alpha, and beta. But you should take a note of the frequency and amplitude. Delta have high amplitude, the highest amplitude as you can see, and frequency is lowest in the delta wave. Then we have the alpha, which have 50, that is amplitude, microvolts, microvelocity, something like that. And we have alpha waves which have a frequency of 8 to 13. All right. Then we have the theta waves which have frequency of 47. This is 10 amplitude. We have 5 to 10 in beta, 14 to 30. So highest frequencies in beta waves. As you can see here, this is the beta wave. We said 13 to 30, the frequency. First is a faster wave. Then we have the delta and theta, which are the slowest waves. As you can see, frequency just for frequency is number of cycles per second. If it is 30, it means that is a faster, very fast, very fast. All right. So you can see alpha. Alpha said has 50, and this is 813 the frequency. Moderately faster. Okay. Sleep. This is a state of unconsciousness from which the individual can be aroused by sensory or other stimuli. The guy can wake up. Okay? When asleep, an individual is not aware of the environment and is unable to perform activities that require consciousness. It's a state of unconsciousness. And during sleep, the stimulus pulse transfer becomes less frequent between the reticular formation and the cerebral cortex. Last time we saw that we need the reticular formation in wakefulness. So the transfer or tonic activation of the cerebral cortex is reduced during sleep. It is less frequent. Okay? Sleep and wakefulness, like many of the body's regulatory mechanisms, have circadian rhythm of about 24 hours. And a newborn infant has many cycles of sleep and wakefulness in the 24 hours. But after the age of 2 years, a single sleep-wake cycle is established. These are facts and you should note them. And in a normal adult, the sleep-wake cycle called a single. So the sleep-wake cycle consists of 7 to 8 hours of sleep, 16 to 17 of wakefulness. So in a single sleep-wake cycle, you'll find that the individual sleeps for about 8 hours or 7. Okay? How do you control the sleep-wake cycle? Like any other circadian rhythms, the control is endogenous. The biological clock which controls circadian rhythms is the suprachiasmatic nucleus of anterior hypothalamus. Alright? Anterior hypothalamus. We have this nucleus, suprachiasmatic nucleus, that is controls the circadian rhythms. And sunlight is a powerful timing cue. Light entrains this rhythm by means of retinohypothalamic tract. This tract is very important. Although the suprachiasmatic nucleus regulates the timing of the sleep, it is not responsible for the retinal hypothalamic tract. Although the suprachiasmatic nucleus regulates the timing of sleep, it isn't responsible for the sleep itself. Sleep is caused by other factors. Okay? So let's talk about the factors which minimize sensory stimulation and favor the onset of sleep. Recall would say that sleep occurs when there is reduced activation of the cortex. So we shall look at the factors that reduce sensory stimulation and favor onset of natural sleep. 1. If you stay in a darkened room. 2. If your surrounding temperature is comfortable for sleep to occur. 3. If you're very silent, you'll sleep. Physical and mental relaxation is a cause of sleep. If you consume basic urge, such as hunger or sex, okay? After sex, sleep occurs. Low frequency stimulation, such as by patting or knocking in a cradle, or when you're sitting in a moving vehicle, okay? That will cause sleep. On the other hand, anxiety and emotional stimuli by release of epinephrine cause activation of the reticular activating system. Anxiety or emotions cause release of epinephrine. This is released in stress, and it will cause activation of the reticular activating system and make sleep more difficult. Yeah, sympathetic activation of epinephrine release makes sleep more difficult. Sleep is of two types. We have the non-REM. REM means rapid eye movement. Non-REM sleep and rapid eye movement sleep, which alternate in a sleep cycle. Okay, let's talk about non-REM. It has four stages. Why is it called REM? We shall see later. Okay, there have four stages. In stage 1, there is considerable sensitivity to sensory stimuli. However, mild to moderate stimuli are often unable to produce full arousal. When you moderately stimulate this individual in sleep, arousal will be partial, it won't be full, okay? And stage 2, we have auditory stimuli during this phase capable of evoking the K complexes in the EEG graph, okay? So they also occur spontaneously during this stage. So in stage 2, when the individual is asleep in non-REM, auditory stimuli can cause some K complexes seen on this graph, or we shall see it. Stage 3 is characterized by an EEG that displays high amplitude. Okay, I'm just talking about the four stages, and it is slow. These high amplitude waves are very slow, with frequency of 0.5 to 2 Hz, and they are called delta waves. Stage 4 of non-REM, or the stage of deep sleep, produces EEG pattern of dome-like very slow, large waves called delta waves. So basically we have delta waves in 3 and 4, but those of 4 are very slow, those of 3 are slow. So another thing to note is that in the 4 stages, we are having, we can call this one very deep. It's called, I've seen it somewhere, stage of deep sleep. This is moderate. This is light. Oh, very light, moderate, deep. Okay, that is it. Deep sleep. Look at this. I've been talking about the K complex. Yes, these 4 stages of non-REM sleep. When you're awake, you can see the graphs, the curves, very high frequency. When you sleep, you can see the frequency, and this is delta wave, this is delta wave. So you have a spike, or what you can call complex. Sleep spindles are seen. So K complex is evoked by auditions, which occur when the individual is sleeping. Okay. Muscle tone decreases progressively during non-REM sleep. So these are physiological changes which occur. Physiology. So physiological changes during non-REM sleep. One, muscle tone will reduce progressively. Two, heart rate and blood pressure will be decreased in non-REM sleep. Respiration rate will also be decreased. Eyes begin slow rolling movement until they finally stop in stage 4 with eyes turned upwards. Alright, body metabolism is lowered and the pituitary gland will show pulsatile release of growth hormone and gonadotropin in the non-REM sleep. Behavior changes during non-REM sleep. The other ones were physiological. So behavior, you can see these ones. Respiration rate, heart rate, muscle tone, body metabolism will be decreased. Eyes begin slowing movements until they turn upwards. We have release of some hormones, growth hormone and gonadotropin. And behavior changes during non-REM sleep. One, consciousness reduces progressively. Two, there's increasing resistance to being awakened. It is more difficult to wake up a person from stage 3 and 4 than it is from 1 and 2. And as well, it's more difficult to wake up a young person than an elder from sleep because elderly people spend less time in 3 and 4 stages of non-REM sleep. Alright. When awake, this person does not report dreaming, non-REM sleep. And there is some response to meaningful stimuli even in the sleep, which indicates that sensory processing continues at some level after the onset of sleep. Alright. Physiological changes during the REM sleep. First, the rapid eye movements are the hallmark. Saccadic eye movements allow the sweeping of visual images of dreams. So in this stage, the guy is dreaming. And to remove the visual images of dreams, they will occur rapid eye movements. And that's why it's called REM sleep. Heart rate and respiration rate become irregular. You can see irregular, not irregular, okay? Muscle tone is reduced due to inhibition of spinal motor neurons via brain stem mechanisms. Alright? Snoring during sleep results from partial obstruction of airways caused by relaxed tongue in supine position. So snoring usually occurs when the person sleeping is in the supine position. Twitching of limb musculature occurs occasionally. Twitching of the muscles, okay? Middle ear muscles are also active during REM sleep. You can see that. Penile erection in males and engorgement of clitoris in females may occur during REM sleep. Alright? Thermoregulation becomes impaired. So when there is ambient temperature, sweating or shivering do not occur. Less in the REM sleep, but in the non-REM they will occur. The response to temperature will occur. Shivering or sweating, okay? The last, bruxism, may be seen in children. That is teeth grinding. Is also a physiological change in the REM sleep. Let's talk about the behavior changes during REM sleep. One, it is very difficult to arouse this individual from REM, as it is from deep sleep. Okay? However, when awakened from REM sleep, the individual is immediately alert and aware of the environment. Okay? Dreaming, because beyond REM, he cannot sleep anymore. Alright? And dreaming occurs during the REM sleep, so it is called the dream sleep. And there is vivid recall of the dreams from approximately 80% of arousals of the REM sleep. They'll be able to recall what they dreamed. Okay? So you can find the sleep cycle and clinical correlates of sleep in the next video.